Okay, welcome back to part three. Now we're going to apply the same rules as we had before for balancing redox reactions to what we'll call a disproportionation reaction, where we're going to have a single reactant that's both oxidized and reduced. Okay, so in the example that we have on the sheet, this is chlorine going to a chloride as well as a chlorate. Okay. So the steps that we're going to follow the same as before. So step one is we're going to break this into two half reactions. Okay, so it might not be obvious at first that we're going to use the chlorine for both half reactions because as we let's see, as we're going to want to do the oxidation reaction, so we can double check it to see that this is the oxidation reaction, but since it's picking up actual oxygen atoms, maybe it's not that surprising. We're going to go with chlorine here, and we also have chlorine going to the chloride. Okay, so with that much done, we go on to step two. So balancing everything that isn't oxygen or hydrogen. So in the top row, we have two chlorine atoms going into just a single chlorine atom. So we'll add on a second one here. And we have the same issue going on the second side, so add a second chlorine there. Okay, so at least our chlorines are balanced. Now let's look at balancing oxygen. So we balance oxygen by adding the correct number of oxygens or the correct number of waters onto the side that's missing the oxygen. So on the product side of the top reaction, there are 6 oxygens altogether. So we'll have to add on 6 water onto the reactant side. So that gives us enough oxygens to meet the need. Okay, no oxygen on the second row, so we're good there. Third, we're going to balance the hydrogens. And again, here's where we have to really check to see the pH of the solution that we're doing it in. This specifies basic media. So again, we're going to use the acid that's in the solution as the source of the hydrogens and just remove everything else by using its conjugate base. So in basic media, the dominant form is going to be the hydroxide. So that's the base that we're going to use to get rid of everything that's not that extra hydrogen. And we'll use water as the acid because it will have one more hydrogen than hydroxide has. Okay, so to balance out the hydrogens, bottom row, there's no hydrogen there. Top row, there are 12 hydrogens altogether. So in order to do that, we're going to add on 12 water onto the product side. Okay, and we will balance that all out by adding 12 hydroxide, since this is basic media, onto the reactant side. So at this point, if you want to, or we can do it later on, there's no need to have 6 water on one side and 12 on the other. We can just kind of cancel out the water on the reactant side. And why don't we move our hydroxide up into that row just to make it a little bit more clear. So we have 12 hydroxides, and we only need 6 over here now. So again, you can leave it as having 6 waters on the reactant and 12 on the product. But at the end of the day, we're just going to cancel them out anyways. This is just cleaning it up a little bit as we go along. Okay, so now we've balanced the chlorine, we've balanced the oxygen, we've balanced the hydrogen. There's nothing else to balance in terms of atoms. So the only thing left is to balance the charge on both of these half reactions. And again, we're going to do that by making sure that we have enough electrons on both sides to balance them all out. So you'll note on the reactant side of the top row, 12 negative charges, 12 hydroxides. Over here, we only have 2 negative. So to balance that out, we need to add 10 electrons onto the product side. Okay, so to balance the bottom row, there's a 2 negative charge on the product. This side is neutral. The product side is neutral, or the reactant side, sorry. So in order to do that, we're going to have to add on 2 electrons. And since we know we want to sum these back together to get one balanced reaction where we can remove all of the electrons so we don't see those at the end of the day, we need to balance this bottom row so that we also get the same number of electrons as we have on the top row. So we'll just multiply it through by 5. Okay. So multiplying by 5 gives us 10 electrons, 5 chlorine, and 10 chloride. And now we're done. So when we go to sum them together, we can cross out the electrons. They balance out. And what we're left with is 12 hydroxide plus, now we have, you'll note we've got 5 chlorines here and 1 chlorine here. So 6 chlorines altogether. Okay, going to, we got 10 chloride plus 2 chlorates and 6 water. Okay, and if you really want to impress us on the test or on an assignment, just reduce this to the lowest number. They're all divisible by 2, so just go through and we can switch that into 6 hydroxide, negative sign, 3 chlorine to 5 chloride and chlorate. Okay, and 3 waters. And for completeness sake, make sure to put the state of each of these. So this would be gas. It's going to be aqueous, aqueous, and liquid. Okay, and there you have it. That's the complete balanced reaction for a disproportionation reaction for full marks. Okay, so we'll stop it there. Please feel free to look through your book and find other examples to balance in basic and in acidic media. It's only to your benefit, and we'll pick up next lesson talking about electrolytic cells. So now we're going to start bringing 2 different half reactions together to make essentially batteries. Okay, thank you very much, and we'll talk to you next time.